we're going to pivot now, and we are going to have a new presentation that's going to be provided virtually. And the presentation is from Dr. Kristie Rowley, who's the principal data scientist and senior manager of data science at Domo, and Steve Guitron, who's a senior data scientist and data science professional services at Domo as well. They're going to be talking about optimizing your marketing efforts with data science. This is obviously something that's near and dear to our heart, given our theme for this year's conference is growth marketing and how we're leveraging AI, machine learning, and data science to make that happen. And where you can be successful or where your efforts fail. And we really think this is something that we have to look at. If you go back to what Colin had mentioned earlier in the day, that only about 6 to 7% of all AI-based efforts are actually executed in practice. There's a lot of times that we fail during this, but there's a lot of learnings that have come from that as well. And that's why we're here today, is to share that with each other. So just a little bit about Kristie. So Kristie is the principal data scientist at Domo. She manages the Domo's data science professional team. And she earned her PhD from Vanderbilt University and has worked in data science as a consultant for over 30 years. We also have Steve joining us, and Steve is the senior data scientist, as I mentioned, at Domo. Steve delivers data science-driven solutions and insights to all Domo customers. His experience is in data science and ML work, and he has his master's degree from MIT. So I am going to remove myself from the video as quickly as possible because I am bringing down the average GPA here. So I'd like to introduce virtually, we have Kristie and Steven. Thank you so much for joining us, and welcome.
Wonderful. Thank you, Kristie. All right. Can you see my slide advancing, Kristie?
Yes.
Perfect. All right. So I'll just get started then. So as you all know, data science has had an immense impact in the world of growth marketing, from targeted forms of online advertising to predictive customer turnover. There are so many tried and true applications of data science that it's fundamentally changed the nature of marketing, especially with the push, right, to online today. You think every application of data science is a surefire success, but in our experience, it's just really not. And in fact, if you look at this statistic from Gartner, only 15% of data science projects are ever completed. And just 2%, that's this tiny little delivers value to organization up here on this chart, only 2% generate real value for the client. So with all the hype and success, why is this? And if this is true, then what can you do to avoid falling into a data science pitfall? What can you leverage to make sure that your data science initiative adds real value to your organization? So that's what we're going to get to today. So of course, Kristie has a lot more experience than I do, but together we have a collective 40 years of experience in various industries and various organizations, from nonprofits to enterprises, manufacturing, healthcare, academic, corporate, but especially marketing use cases. That's something that we definitely see a lot of. We've seen many go right, and we've also seen many struggle. So our job is to make sure that your initiative succeeds at delivering the kind of value that you need in a data science endeavor. So what impacts whether a data science initiative succeeds? In our experience, we found some insights that we think are common among those that succeed. And so we collected that into 5 different things that we think would be very helpful in determining success. So those are starting and ending with the business question, not the data. Assessing your data accurately before engaging in any modeling. Be careful interpreting trends and causality. Data science solutions are determined by the problem, not the technology. And then make sure your solution is powerful, scalable, easy to use, and resilient.
Okay, so let's start with the first one. Start and end with the business question, not the data. Fundamentally, this is really the difference between science and data exploration that might not fall under the science category. As an example, in science, we use deductive reasoning. So we start with hypotheses, and then we formulate tests, and we evaluate those ideas based on the tests that we run. Inductive reasoning, on the contrary, starts with the data and we derive conclusions from those data. Those are two fundamentally very different processes. And in data science, it's very common to think, well, we're stuck with the data that we've got, so we're going to start with those data, and from those data, we'll use data science and derive answers. But when we do that, we're skipping really fundamental phases of what makes data science science. And we tend to go down the wrong pathway in terms of addressing the business questions that are really important to us. So we always want to start with a deductive approach. That deductive approach can start with a really good business question. So I'll give you a marketing scenario. A major apparel department store finally collects customer purchase data into a unified data warehouse. So, and this is a success, right? When you can get marketing data all in one place, that is absolutely a success. So naturally, we want to start asking really useful questions with those data. The CEO may ask, how can we get customers to buy more clothes? A common question. This is the goal that almost every retailer wants. We want customers to buy more stuff. But is this a good data science business question? Our answer is no. This is not a good data science business question because it is an unmeasurable business question. Now, unmeasurable doesn't mean bad. You have to start somewhere. And this definitely points us to places that are very important to the business. But how do we work with this question to turn it into something we can measure and formulate hypotheses around? We often walk our customers through this process where we start with an idea and we move them towards clear, measurable outcomes. And that helps us clarify business questions and narrow down the scope of what we want to do effectively. So we often start firstly with something that's unmeasurable. How can we get customers to buy more clothes? And then we move on to something that's a little more descriptive. We frame that question around something that we can measure. Very common for the next step to move to descriptive. How many customers who received advertising from a specific ad campaign made purchases? Now, obviously, that's not a data science question. We're looking at past history. We're not trying to predict anything. It's important to understand the information that we do have, however, to move forward with hypotheses. So then we can generate those hypotheses and we can formulate that business question that's a little more predictive and falls squarely in the data science camp. And it might look something like this. Based on purchase history, which customers should we target for each of our 3 advertising campaigns? That's squarely in the realm of data science, and this is where we like to be. This is something we can measure. After we figure out that business question, each of them need to be assessed individually to see if data science is the right fit. Data science might not always be the right fit, so we start with the question again. So we define that question as we just barely walk through. Once we do that, we gather hypotheses, we formulate hypotheses. However, we don't let these hypotheses necessarily dictate the direct causal relationship that we're trying to investigate. We may have a lot of different hypotheses. That's often true in marketing. Once we do that, we do blue sky thinking, like whiteboarding, identify the mechanisms that we think drive an outcome. So this would be clothing purchases. What drives that outcome? And don't limit yourself. The sky's the limit. Draw everything on your whiteboard. Figure out what you think is the most important and let your ideas and your expertise govern how you think about those relationships. And once you have those, then we can look at the data. If we think that data science is only about the data, we miss these fundamental steps that help us ask the right questions and get the right fit and make sure that our data are actually working for us instead of governing what it is that we do. We always want to be in the former, not the latter. All right, with that, if we're defining a business question, we always want to involve all the stakeholders. Oftentimes we think about executives, and absolutely they are important. The business stakeholders are useful. It's also really helpful to talk to frontline workers as well. The on-the-ground staff will often have really, really valuable insights, not only about what the business question should be, but how those mechanisms work and how our hypotheses should shake out. They often have really good ideas on how they could use a final solution that deals with data science as well. So we don't want to overlook them. Only then will we bring in the data experts And along with that, often the tech experts and the data scientists. Once we have really solid business questions and give those data scientists really good directions on how to go and how to think about the relationships in the data that we're looking to see, they can give you some really good advice on how to proceed to the next steps.
All right. So our second key is assessing your data accurately before engaging in any modeling. This is really important because it allows you to avoid pitfalls and wasting resources if you move on to the modeling step, right? That could be discovered during the data step, looking directly at the data. So let's take a look at another scenario. We have an electronics retailer that's investigating whether an ad campaign affects purchasing behavior. So the data initially looks comprehensive, but further analysis reveals that the ad was shown to every user during the data collection period. So if you show it to every user, then you don't have a negative example. So without a control group, it's difficult to make any conclusions about the campaign success. This is just one of the many issues that we've seen if you assess your data before applying any modeling. And it's an easy issue to pick out, right? If you take a look at the data. And again, if you find this anomaly before you've invested significant resources in development, then you got a better chance of pivoting towards something that is more successful. So data really is at the center of your endeavor and will determine the direction of your project. And as such, data quality can really be the key difference between success and failure. Just like on the previous slide, that's an issue, right? Not having control. But there are many issues that can be discovered during the data assessment phase. And so we've listed some here. So first, are data reliable, such as hand-entered data? So is there a significant difference between hand-entered data and automatically collected data? We've seen that there's a lot of differences in that. Or if there are mutually exclusive kind of buckets of data. So suppose you have many features for maybe if a person is between 18 and 25 and then 65 and above, right? If you have a data entry, right, that has both of them marked as true, that's just not true, right? And that's not mutually exclusive. So data reliability is one of the most important things to check before you start on a modeling endeavor. Are features well defined with minimal missing data? This is really important as well, because sometimes a customer is so excited because they have all of these features and 30 million rows and whatnot. But if 80% of many of the important features are missing, then it's almost as if you had none. Are features relevant to the business question? Again, if you have a lot of features, right? But when, like Kristie said, when you make that conceptual model where you're blue sky thinking about what directly affects the outcome, if you don't have the features that directly affect the outcome, then no matter how much data you have, it may not be predictive. So are the data measured with the right granularity? This one is, for example, if you're looking at customer purchase data and you want to predict on a daily basis, if you have it on a weekly basis, then you just can't do that. Are data static or overwritten over time? For me personally, this is one of the most nefarious of the data quality issues, because if it looks perfect, you have all of the data, nothing is null. But if things are overwritten, so for example, let's just say you have purchase data and if someone makes a return, that purchase entry is deleted. Then you don't have that to make a prediction on, and you don't have that information. It's lost just because of the data pipeline issue. So it's really, really important to check to see if it's static or overwritten over time. And then are there sufficient data points? Not just in terms of the amount of data, but in terms of what, if you want to measure things. So for example, if you want to take into account seasonality and you only have a year of data, you're not going to be able to do that because you don't have more than a year. So it's good to take that into account. So it seems with all of these, data quality issues, you're probably wondering, well, what happens if I do have all these issues? And we do see it a lot. Does that mean that it's doomed to fail? Not at all. Data science, we like to think of it as a journey, and you can get value in a lot of different ways than what your originally scoped use case might suggest. So, for example, one of the things that you could do after after seeing that the data doesn't support your use cases, you could collect more data. And if you think of data science, a very underrated aspect is that data really is an asset. And what I mean by that is that you can invest in the pipelines that would allow you to collect the data that you need That's really a quality issue, right? Seeing, for example, if you don't have returns data, right? Maybe you can set up the pipeline to collect that in the correct way. Or it could be quantity, right? Maybe for a particular use case, you have to collect a lot more data in many years, right? And so it's a matter of waiting for that to happen, or perhaps finding new ways of getting that quantity of data. You could also reframe the question. So back when you're deciding what business use case to pursue, right? Maybe there's a way to adjust it or think of it differently. So for example, maybe you want to predict the amount of purchases, but what about predicting if a customer purchases at all? Reframing it from a regression to a classification problem. This is something that you can do at this stage and see if the data can support that. Lastly, you could scope down the project. So for example, if you have a collection of data and it seems that you don't have the right data for most of the data set, but you find that a very high impact segment of your population has very good quality data, then maybe you can narrow it down, right? Narrow it down to that segment, and you'll be able to create a predictive model within that segment that will definitely drive value within that segment. So in conclusion, really, it's a journey, and I think that the data really points you into the direction of where your solution is going to go.
Next, once you have a data science solution, it's really important to understand how you can interpret that. We see one of the biggest issues is interpreting trends or correlations as causality. So let's talk about some of the differences in that. First of all, identifying causes or why things happen is usually what most people want out of data science. And they often come to data science saying, well, what will the outcome be? But that's not really what they want to know. They want to know what will the outcome be and why is it going to be that? So that why question is really important. However, most data science efforts are good at predictive sorts of things, but they're not necessarily good at determining cause. So they're good at looking at results, not always good at determining why those results happen. So what do we need to do about that, and how can we understand that better? And how does that influence your project? We'll take a look at a marketing scenario. A book retailer is looking for geographic areas to target with a new ad campaign. Along with that, they take a look at some results from the data science analysis, and it shows that a certain zip code is associated with high spend following an ad campaign. So it might be reasonable to assume that that zip code causes more spend for whatever reason. We don't know the mechanism, but that zip code causes more spend. But you take a look at it a little bit more, and if you look at the historical trends for this particular zip code, this zip code may trend upward for book purchases in a given month in which this particular analysis represented, regardless of ad campaigns. So ad campaigns might not actually have any relationship at all. It just looks like it may have for one particular month. So this could lead to a lot of spend on targeting an ad campaign in a certain zip code that would be wasted. It would be a waste of resources because we didn't interpret causation in the correct way. And there are a lot of ways that we can think about causation. We will go through those next. First of all, you want to make sure that you have robust data points. That's the number one piece. So are the data something that we can really put our trust in? In this particular example, you can look at a trend line. This is amount of spend per ad shown. And over time, that tends to go up, except for it takes a nosedive and then goes back up. So we may assume just by looking at this that one particular ad was ineffective, or it didn't work. And we might dig into why was that one ad ineffective. But if you look further and we explore the data points a little bit more, what we really see is the data collection efforts weren't very good. So we've got number of data points as the bars, and we have really high amounts of data for the first 6 bars. And then by bars 7, 8, and 9, you see really low amounts of data, and low amounts of data often might be polarized again with outliers and things like that. So we may not have reliable data here. So we always want to make sure that we're looking at the right thing and that we trust the data that we're looking at. This is one of my favorite ones. This is when you get a PhD in something like data science, you spend a whole semester on stuff like this. So this is fun to look at. You want to be careful with correlations, and most of what we do in data science is examine correlations. Sometimes we can get at causation, but that usually requires a little bit more rigor. And we'll go into that a little bit more. But let me go over this chart first. So this is worldwide non-commercial space launches in the red line, and sociology doctorates awarded in the US. So if you just look at these correlations, and these are correlations, you may draw the conclusion that sociology doctorates are correlated with non-commercial space launches. If you take that one step further, which seems ridiculous in this example, we could say that the more sociology doctorates we have causes more non-commercial space launches. Now, since sociology doctorates really don't have any mechanism associated with space launches, that would be ridiculous. But if you think about it in a different way, you can see how this would happen all the time. For example, I've seen in marketing efforts or in sales, for example, one salesperson dominating the sales for a quarter or whatever, and the results are that salesperson caused higher sales. But do we know that? Do we really know that? Maybe you dig into it a little bit, and what really happened is that salesperson offered more discounts than everybody, and so they had higher sales. So maybe it was pricing that caused higher sales, not necessarily the salesperson. The salesperson was just the mechanism. So we want to think about a few things when we talk about causation and correlation. The first thing you have to determine causation is association. And in this chart, we do. Sociology doctorates and non-commercial space launches are correlated. They follow each other. However, what we don't have is the second threshold that we have to cross for causation, which is time order. We have no evidence that sociology doctorates were awarded before the non-commercial space launches. Therefore, we don't know if it could cause it, because this just shows correlation. It doesn't show causation. So we don't have time order. Time order is essential. So we have correlation, we don't have causation. We can look at this and understand that there is some spuriousness happening. So spurious variables or lurking variables or confounding variables are something that's driving both trends. In this particular case, I'm comfortable indicating that perhaps economic expansion and times of economic growth drive both of those trends in either an upward or a downward trend. So spuriousness is something that we have to account for. So those are the three common causation thresholds that you have to cross. There are a few others that we could discuss. In the interest of time, we won't go over those, but you always want to make sure that we're talking about correlations and causations in the correct way as to not confuse our end users with our data science results.
All right, so number 4, data science solutions are determined by the problem and not the technology. This is a very, very common thing that we've seen where usually a customer would be excited because there's this new technology or this new algorithm or some new way of applying something, right? And we're looking for a use case. We're thinking, how can we apply this to our business? We got the data, we got the tech, right? But it really needs to come from the use case itself. What is actually going to be drive value, but also what is going to be used, and how can you devise something that can not only be made, but applied and utilized to change workflows for the better. So let's take a look at another marketing scenario. So we've got a gym chain, and they built a black box model that predicts whether customers will renew their membership very well. It's a great model. But the problem is that little action can be taken with the current information because it is unknown what factors cause the customers to renew, right? Other than, for example, looking at the ones that aren't and then maybe just giving phone calls or texting or whatnot. There's not that information that could have been found if you looked at the original use case. And that's why this application was entirely successful, because while you can make a very advanced model, it's really about that next step, right? Putting it into production in a way that can be used, that really, really matters. So data science really is a science. And what does that mean? It's more of a process that comes from the use case directly and not from any other part, like from the technology, the algorithm, et cetera. So let's take a step back and let's look at the marketing use case from the previous slide. So this is the use case. Which customers will renew, and how can we use that information to convince customers not to cancel? So now we move on, and the use case determines the strategy, right? And the strategy comes from the use case. So our strategy is going to be, well, let's predict the customer lifetime value. That's the membership duration. And then what we're going to do is we're going to use an interpretable model. That way we can see the factors that affect that CLV. Then the strategy would determine what tools we use, right? To regress on the membership duration, right? Or to predict that. We're just going to choose a gradient boosted decision tree for modeling, and then look at feature importance, a combination of partial dependency plots, possibly to visualize the relationships between features and outcome. Again, this is just one of many tools there are, right? But the tools are determined from the strategy. And you really want to choose that so that you can complete all of the objectives in your strategy. And then once you select the tools, you build the solution, and then you're ready for the results. So use case determines the strategy determines tools, and tools determine the results, and it really needs to go in this order. The use case, we've seen many times, a lot of times, if a project lasts for even a long time, right, people will not forget, but it's like deprioritize the use case, but that really, really needs to stay at the center of everything that you do. So in the previous slide, we suggested a machine learning model as the tool to achieve the results that we need. But there are all sorts of tools in the data science tool set. So machine learning techniques, that's definitely like the biggest aspect, right? And is the only way that we can perform predictive modeling. But there's other techniques that we found are immensely valuable and quite underrated, right? So take focus groups, for example. If you're looking for reasons why your customer may be canceling their gym membership, sometimes it's best just to ask, right? Just to ask a collection of customers, right? You can think of even online reviews as sort of unfocused focus group, but the real value is asking questions, gaining insights, and just being face-to-face and getting the insight of your customers directly from the customer. So another technique that I've personally found very, very valuable are interviews, just interviews with people. A lot of times you can find out so many things from the experience, right, of people that's just not in the data, or the experience of people can help you to interpret the data. That's really, really important, because then it's a matter of connecting data to real life. That way you have a better intuition and you can apply that throughout whatever solution you're going to develop. And then lastly, surveys are great when you want to combine the qualitative nature of an interview or focus group, but with the quantitative nature of data science. Survey results, like how do you feel about this on a rating of 1 to 5, right? This is very easy to translate into a data set, and then you can apply those same predictive analytics on that. So really consider the value of qualitative data when you're looking at data science use cases and also solutions. Despite the applicability and pervasiveness of digital marketing in today's world, and it is very valuable, qualitative data really can reveal some fascinating insights.
Once you have your solution and you followed this great path forward so that you're in that 2% of data science efforts that are successful and useful in a business, the tech does matter. So, and my shameless plug for Domo is that that's really what we're trying to do as we develop our data science product, is to make these solutions powerful, scalable, easy to use, and resilient. So what does that mean, and what are we looking for when we're looking for all these characteristics in a technology to deliver data science? Let's start with a scenario. An architecture firm has designed a dashboard to visualize their data science model to predict high growth segments. They have a great model. It's awesome. They want their whole business using it. They want their on the ground folks using it. But when people try to use this solution, there are several problems. First of all, there's kind of a clunky UI. It's not intuitive. It's hard to visualize. It's hard to use. Many of the data filters that are required for visualizing the results are hard-coded, And so that creates a manual process. And manual processes are just annoyances for data scientists to manage. And they become really difficult for end users to navigate around because they lose trust in the technology and they lose trust in the results when they don't always get to see what they need to see. There are also extraneous numbers, information, etc., in the solution that complicates it. So how many times have you worked with a data scientist who's super excited to show you their confusion matrix and their regression coefficients and the high quality of their analysis and then their feature importance measures and all of this, and you just look at it and your eyes glaze over and go, I don't know what you're showing me. A lot. This happens a lot. So the results for a data scientist and the ones that data scientists want to visualize are not always the ones that are the most beneficial for the business. So we don't necessarily need to show all of those together. And when extra things are added to your results that end users may not need or may complicate the solution, I think people easily come to the conclusion that data science is too hard to understand anyway. And so it's not usable. It's really hard to get somebody to use something that they don't feel like they have a good grasp of or that they don't understand. Since the goal is to make it easy, we want to focus on that. Also, let's say the solution is in a dashboard, and every time the end user goes to view that dashboard, it takes 10 minutes for it to load. This is a very poor user experience, and unless your organization has a lot of coffee breaks going on, this is absolutely not something that you want people to experience. You want that user experience to be smooth and in real time, or as much as in real time as you can get. And lastly, maybe the primary stakeholders are never trained to use the solution. As an example, I have seen several data science solutions that were awesome. They were really good. The models were really predictive. But as awesome as your data science solution might be, your predictions are never going to be 100% perfect. And people might not know how to navigate things like false positives or false negatives. Or they may not be instructed on what to do with the information. So for example, I have done many HR use cases where we predict employee turnover. And if an employee is expected to turn over in the next 3 months and a manager gets an alert that says, oh, this employee might turn over, and the manager doesn't know what to do with that information, then they may do something like go to the employee and say, hey, so I got an alert that says you're thinking about leaving the company. And then maybe that person's not even thinking about it. So they don't even know where this is coming from. And that causes them to mistrust the organization. It might actually drive turnover higher. So if primary stakeholders are not trained on using the solution, they won't use it, or they'll use it poorly. And then your data science will defeat the purpose for which you created it. So let's avoid all of those. We can do that by providing solutions that are powerful, scalable, easy to use, and resilient. And we've put a whole bunch of questions up here that Steven is going to populate on the screen as I talk. But basically, what we mean by powerful is that it is intuitive and provides useful information. Scalable means that it can be automated and rolled out to broad audiences with information specific to the audience. Easy to use also means that lots of different people can navigate it, and it can be created and curated explicitly for the people that you want to be able to use it. Resilient indicates that there's specialized alerting, and the right people can be alerted appropriately when something breaks, and that doesn't necessarily affect the user experience. We don't want to interrupt the user experience. We want it to be resilient. We want it to be automated. We want to be able to incorporate changes in real time. So these are the things that we're thinking about when we think of good data science technology.
And with that, we've rounded up the 5 keys to a successful data science initiative in our experience. So I'll just go over it one more time. Start with the business question, assess the data, be mindful of trends, keep the use case at the center, and make your solution an indispensable tool so that you, your organization, and your customers can discover the true value of marketing data science endeavor. Thank you very much.
Thank you so much, Kristie and Steven. That's really useful information and very actionable points that you talked about. So we really appreciate you going through those. We do have a couple questions to go through. The first one being, we are new to using data science to direct our marketing efforts. Where would you suggest that we start?
I will go ahead and take that one. I think that's a great question. Where do you start? It can be overwhelming. I think it can be very overwhelming, actually. I would always start with what you've got. Start by talking about what's important to your business. Start by investigating the things and the problems that you really want to solve, and then go through the process that we outlined with formulating good business questions and move forward from there. And if it takes a long time to do all of that groundwork, it's worth it. I think one of the worst things you can do in data science is jump to the modeling, just because that's what you want to do, and that's what we often associate with data science. It's really important that we lay that foundation really well by thinking about what we're doing. It also allows everybody in the business to really demonstrate their expertise and rely heavily on that expertise. The more expert you are in the knowledge domain, the better your data science is going to be in the long run as well. So I think that those are really helpful. Steven, do you have any other thoughts in addition to that?
No, I think that you covered it pretty much perfectly. So.
Great, thank you. Next question on our list here is, based on your experiences, what do you see as the largest point of failure for data science efforts?
I think I'll take this one. So something that I mentioned back in the slide deck was keeping the use case in mind. You'd be surprised how often, and I think a lot of it depends on the length of the endeavor too. Sometimes it's very easy to lose track of that original question that you're trying to answer. And really throughout the whole process, right, of a data science endeavor, you've got to keep that question central to everything you do. Otherwise, you'll utilize resources on just kind of tangential questions, right? Or maybe tangential items that have little to do with the actual use case that you're trying to pursue. I think that there's a lot of really interesting things that you can do, right? But at the very center of it, you got to ask, is this going to help the use case? And is it going to help people to use this solution once it's done and to use it for the long term? So I really think that's one of the biggest points of failure. What do you think, Kristie?
Oh, I agree with that. Coupled with, there's so many points of failure. You highlighted, Steven, that 98% of these things either aren't usable or never get through to completion. Keeping your eye on the ball is absolutely essential. And making sure that you have patience too. These are often really long endeavors, and you have to put the time into every stage to make sure that you get there. And skipping stages, especially at the beginning where you're laying the groundwork, is tempting to do, but generally not productive. So I think it's worth it to keep your eye on the ball, and then also make sure that you're doing your due diligence to spend the necessary time and effort in every phase.
Absolutely, thanks so much. Our next question is, do I need to have a data scientist on my team to effectively avoid pitfalls in our data science efforts, such as the ones that you mentioned in your presentation? Or is a citizen data scientist sufficient?
I think this is a good one for you, Kristie.
This is one of my favorite questions. Steven knows this. I honestly feel like citizen data scientists are sometimes underutilized. And really good data analysts, I think, can be underutilized. Just because they don't have data science training per se, doesn't mean that they don't have an amazing skill set and an amazing grasp of the business data that they're working with and dealing with every single day. Having said that, it's really hard to navigate the whole entire project in a direction that supports data science if you don't have a data scientist available, either on your staff or a consultant or whatever. But data scientists don't have to do 100% of the data science work. I think there are a lot of analysts and citizen data scientists that can be underutilized, and they can be empowered with the right person directing their work and overseeing what they're doing, where you can come together and you can bring analysts and the business analysis, BI and AI together in your business ecosystem that really support each other nicely. I think too often we put BI in a corner and AI in a different corner, and they never talk to each other. And I think that that can be one of the downfalls of both AI and BI in the long run. So when they work together, I think that's way better.
Awesome, thanks. Next question is, how do I hire a data scientist who can effectively do the things that you suggested in your presentation?
I think this one is really hard to do. And if you're hiring a data scientist for the first time, it's very common for the people doing the hiring to feel like, I don't know how to hire this person. I don't feel like I have the technical expertise to hire this person. I may not even know how to advertise for it. I can't assess their skill set. I don't know how to hire this person. I think that's normal, and I think it's okay. You have to build your practice from somewhere. And I think the key there is just being really open and communicating what it is you want the data scientist to be able to do. If you can communicate that, and then you find someone with the appropriate skill set, I think you're set. Now, finding someone with the appropriate skill set is another thing that is hard sometimes. In my experience, and the way that I hire data scientists is I always want to look at their portfolio of work and I want to see them present. If they can present to me use cases that they've done, the use case is specific to what I want them to do in the business setting. So for example, if I'm hiring in a marketing department, I would absolutely want them to be able to present marketing use cases. But I want to see their presentation. I want to see what they do. I want to see how they talk about the data. Can they ask really good business questions? Can they talk about how they refine the business question? Can they talk about blue sky thinking around an idea and then developing hypotheses and matching those to data, exploring the data and making good data decisions and getting results? And most importantly, do I like the results they came up with? Not necessarily the model results and what the model says, but do I like the dashboard they came up with? Could I see myself using it? If they can do that, if they can provide a compelling use case that you want to use with a solution that's really valuable to your industry, they're probably a really good catch. You should hire them immediately. Steven, do you have any other insights?
I would just add on to that kind of communication piece, not just in terms of presenting and whatnot, but just even designing like a final solution, right? Being able to interpret what people want, what is going to be valuable. I think that's really, really key and sometimes overlooked, just that kind of feature.
Great, thank you. We have two more questions from the audience. The first one is, what is a good strategy for working within a large organization with legacy data streams and systems? In an effort to lead modernization, what are the building blocks or baby steps you can suggest for working within this context, especially when there's a push to speed the project to production?
Sure, I think I can start off with that too. I think the first thing is just make friends. Make friends like with people, make friends with the people that know the data, right? Just like Kristie explained, right, with the stakeholder slide, right, where you have to have someone who is going to push the project, right? It's going to be maybe an executive or maybe a manager or someone kind of in the senior position who's going to own the project. But really, it's just a matter of talking with especially the on the ground, right? To really match what's in the data to what's happening on the ground. I think that these things, if you're able to involve all of your stakeholders effectively, then I think that will be enough, even a large organization, to push the project forward. Do you have any other insights, Kristie?
Just in addition to what Steven is saying, I also think setting reasonable expectations is really important. I've been in organizations like that where well, where's my data? Like, I need it tomorrow. You said it would take 30 days and it's taking 90 or whatever it is. Those reasonable expectations have to be set, and adjustments to your timeline have to be navigated as well. I also think it's really important to update the business, not just on the timeline, but what you're getting from that timeline extension. Like, what are you getting from this? Are you able to bring in legacy data that matches your current data? And because of that, you don't have to throw away your legacy data when you do your data science. Like, those sort of explanations and the insights that you're gaining along the way, I think are often overlooked because it's a boring process. It's hard, it's repetitive, it's not fun, it's not the sexy part of data, but it's where you set the foundation and lay the framework for everything that you're going to do in that business. And I think that you can highlight and raise insights along the way that are encouraging and valuable as you're setting reasonable timelines.
Great, thank you. Last question from Pierre Canois. Any advice or good collaboration tools to ensure cross-functional projects are managed in an agile way, i.e. methods or tools to adjust along the way as you progress in real time?
Oh, I like this one. In my experience, really, really good project managers help. In terms of tools, I honestly feel like really good human capital in terms of project managers is more valuable than any other tool that you're going to find in a technology space. That's my personal view. But I'm also the person who thinks that data science is more about the process than it necessarily is about the tech. So maybe that's not the answer that anybody wants to hear. But I do feel like really good program and project managers and their brain power and their ability to negotiate those situations are absolutely the best path forward. And then they will adopt the technology that will help them do their job the best.